Hello STEMmies, this is a video just to help you with the math models if you're still struggling on this. I wanted to kind of give you an example to use as a reference. Feel free to watch if you need to. So what we're going to be doing with the constant velocity cars today is basically predicting where and when the cars are going to crash. So I'm going to write two math models here based upon both what you observe on the screen, and we're just going to kind of make up a velocity for each car. Okay, so let's say for car A, we're going to make car A the red one. Let's say the velocity is, we've already calculated it with Logger Pro, and we're going to say it's 0.39 meters per second. And we're going to say its initial position. If you look at the number line up here, I'm going to pretend this is a meter stick. All right, the initial position of the red car. Notice I lined up the front of the car at 0, which is what you'll want to do when we actually test these. The initial position is going to be at 0 meters. All right, now for car B, we have a starting position or an initial position of 4 meters. And the velocity, again, we're just pretending we checked this in Logger Pro. Let's say the velocity is, I don't know. Let's say 1.3 meters per second. But notice the car is facing towards the origin. So this is going to be a negative velocity. All right, so that just means right here, we're going to include a negative sign. All right, now, to write our math models, we're going to say, we're just going to use the format position equals velocity times time plus initial position. So in this case, for the red car, or car A, our position is 0.39 meters per second t plus 0 meters. And for the blue car, our position is negative 1.3 meters per second t times time plus 4 meters. It kind of looks like a negative over here. That's my equal sign. There we go. All right, so we've got our math models written. Our job now is to basically determine when the position of the red car equals the position of the blue car. So I'll call this car A and car B. And really, this is as simple as just kind of using substitution. So I'm going to center that. And then for car A, on the left side of the equation, kind of think of it as a left and a right side, I'm going to replace the left side with my model that I wrote up above. So we're going to say, for position of car A, we're going to say 0.39 meters per second t plus 0 meters. And that has to equal what we wrote for car B, which was negative 1.3 meters per second t plus 4 meters. All right, and now it just comes down to combining like terms. So for those of you that are still kind of struggling with the units, maybe off to the side you want to think of this as 0.39t plus 0 equals negative 1.3t plus 4. It's basically the same thing. All right, so we have t's on both sides. I like to have positive values, so I'm going to add 1.3 meters per second times t. A lot of people forget that t. That's a term. You have to add the entire term when we're rearranging equations. All right, so if I add that to both sides, we end up with 1.69 meters per second times time plus 0 meters equals 4 meters. All right, now, if you recognize that 0 meters doesn't matter, you can cancel it out. Otherwise, we're trying to get the constants on one side. So I'm going to subtract 0 meters on both sides, and we get 1.69 meters per second times time equals 4 meters. And then to solve for t, we're going to divide by 1.69 meters per second. All right, and I need a calculator for that, so I'll say time is equal to, let me grab my calculator, 4 divided by 1.69, so 2.37 if I round to the nearest hundredth. And then my units, if I cross out meters, we're left with 1 over seconds, and we've done the math on that this year. We realize that that comes down to seconds. Okay, so it's going to take about 2.5 seconds for our cars to collide. We've got some pretty slow-moving vehicles here. To figure out its position, all we have to do now is take one of those models. Since I'm writing in red, I'm just going to go up and steal the red model. My red model said 0.39 meters per second t plus 0 meters. All right, and so what we'll have you do is a pretty simple substitution. Instead of writing t for time, we just figured the time out, and the time was 2.37 seconds. And so to figure out the position of the crash, we're just going to multiply the velocity times the time. And I'm going to take 0.39 times 2.37. Again, your numbers are going to be different, but you can at least follow the pattern. 0.9243. And then my units, well, seconds cross out. That's meters. Plus 0 meters is 0.9243 meters. All right, well, let's check our picture. See if that makes sense. That's just under a meter. So that means they're going to collide. Lost my image. One moment. Let me fix the screen here. Technical difficulties. Okay, there we go. Okay, so again, let's just check for reasonability. That means they're going to crash about right here. See if that makes sense. Car A is only going about 0.4 meters per second. I put car A over here. That was supposed to say car B. Car B is going a lot faster. So yeah, it would make sense that they would meet closer to the red car than the blue car. So the next thing you would do is create a graph and confirm graphically that your solution does indeed make sense. All right, hope that helps.